Hello everyone.
Hi everybody.
Power was just about to explain what it takes to swing the upper carriage.
Yeah, come listen in. Like most functions on our machines, the swing drive is hydraulically powered. Remember the proportional valves? Well, let me give you a quick reminder. If you tilt one of the levers, for instance, the respective transducer in the lever sends a signal to the CMS. The CMS calculates the electric current needed to open the respective proportional valve, which then opens the corresponding spool in the main valve block.
Yes, I remember. Do we use the same components here?
Well, basically yes. Here's a list of the components we will concentrate on. And remember, this is a closed loop hydraulic circuit.
What's the difference between the main hydraulic system of the machine and the closed loop system?
With the closed loop system, the oil flows from the swing pump to the swing motor and back to the swing pump without any direct return connection to the hydraulic tank. And as we know, the flow must be able to travel in two directions to change the swing direction. In the main hydraulic system, the oil flows from the pump to the consumers and back to the hydraulic tank. This is a swing pump. It provides the flow for driving the swing motor over there. Then there is a swing gearbox which moves the whole upper carriage on the slew ring. In all swing circuits we have a charge pump and a flushing valve. For the swing system with two engines there are also blocking valves. Last we have the balance valve. Its job is to control the acceleration and deceleration of the upper carriage when the hand lever is activated in either direction.
Okay, I've seen the components before, but could we take a look inside for a change?
Certainly. Let's take a look. This is a swash plate pump which can produce flow in both directions, and this is what changes the direction which the upper carriage rotates. The swing pump's contamination and swing circuit temperatures are monitored by the BCS.
You want to keep an eye on that?
Yeah, pretty much so. Well, anyway, here we see the two blocking valves which separate the right side swing circuit of the excavator from the left side circuit. This is a safety measure for single engine operation. Anyway, here's the swing motor mounted to the swing gearbox. Here you can see the synchronization hydraulic lines between the two swing motors. And over here, you can see the connection to the swing bearing through the gear pinions.
What is this pump and valve for?
This is a charge pump and the charge filter. I'll explain their uses in a minute.
Thanks for the rundown. I'm sure we'll also be seeing the system in action on the machine.
Now, how do you know that?
Where are we?
On an RH90. It has the most simple of our swing systems on a machine with two diesel engines. Perfect for explaining, you know? Look, there are two pumps. A swing balance valve, four blocking valves, two swing motors, two swing gearboxes, and the mechanical connections through to the swing bearing.
Won't the systems influence each other? I mean, with the two pumps and everything else in the systems?
No, we have check valves in the pilot and main circuit and the blocking valves in the swing circuit to prevent one system from accidentally driving the other engine and pump combination.
Oh, good.
The charge pump always supplies a percentage of fresh and cool oil into the swing circuit. You can observe the pressure of 30 bar on the BCS screen. This pressure is being built up by the oil from the charge pump.
Why does it have to supply more oil into the circuit anyway?
There's always some loss of oil during the swing cycles through the pump, the motor and the flushing valve. And the charge pump compensates for the loss.
Ah, that's clever.
Isn't it? So let me show you how we swing the upper carriage step by step. When the hand lever is activated, a signal is sent to the CMS. The CMS activates the corresponding proportional valve. which sends a servo signal to connection points Y1 or Y2 at the balance valve. A pressure of 31 bar is preset here on the RH90. This causes the pistons in the balance valve to move. Now the swing pump delivers oil to the swing motor through the blocking valve. The motor drives the gearbox, which turns the pinion, which rotates the whole upper carriage. Once the oil passes through the swing motor, it becomes the low pressure side of the circuit and flows back to the swing pump to complete the closed loop sequence. Now, imagine this is a cross section of the balance valve. The larger piston, this is our piston area 12 or 16, which controls the feed for lines X1 and X2 to the swing pump regulator, thus controlling the swash plate angle. The two smaller ones, our area 1, sends the main swing circuit pressure. Force of the large piston is being balanced against the force of the small piston, and force is a result of area multiplied by pressure. The maximum swing pressure is a result of pilot pressure applied to the large piston area against the pressure on the small piston area and the ratio between the large and the small areas. A simple example: 30 bar pilot pressure at a ratio of 1 to 12 equals a system pressure of 360 bar. You have a fully loaded bucket. That's a lot of extra weight to be moved.
Yes, that's for sure.
When the pump is activated, the flow of oil faces a strong resistance.
As you would expect from having to move something very heavy.
Yes. So now the pilot hose connection from the swing circuit sends the high resistance and tells the small piston in the balance valve at position X5 and X6 that the bucket is full, so to speak. Now a small amount of oil is conveyed until a high resistance is overcome. Then the pump is able to convey a larger amount, resulting in acceleration of the upper carriage.
Like shifting gears.
If you want to put it that way. You can clearly monitor the procedure on the BCS screen. Look, X6 stays at 30 bar pressure, while X5 is now at a pressure of 372 bar, as long the superstructure is accelerating and then dropping as the maximum speed of the upper carriage is reached.
Meaning?
The high pressure on the small piston at the X5 connection allows a small opening of one regulator side to the tank through the balance valve. The available 30 bar pressure on the other regulator side takes over and adjusts the swash plate. The dropping main swing circuit pressure sensed at the small piston allows the large piston to take over and maintain the tank connection. The swash plate angle is now continuously increased until the maximum flow is reached. With the maximum volume of oil, the superstructure swings with the maximum speed. Maximum speed is about 5 turns per minute. Note, the hand lever was held in the same position during the whole procedure.
Check that.
Now if you want to decelerate, you push the hand lever all the way into the opposite direction. We call that counter swing. The CMS now provides a servo pressure for the balance valve at connection Y2. This causes the large piston to signal a pressure change to the pump. But the kinetic energy of the rotating upper carriage forces the motor to keep running via the pinion gears. So with the high and low pressure reversed, the swing motor becomes a pump and drives the swing pump as if it was a motor. Now, the kinetic energy is transferred into the pump drive gearbox, supporting the engine with driving the hydraulic system. You can easily notice this by looking at the engine's RPM. When the upper carriage has come to a complete stop, the hand lever is brought into neutral position. Otherwise, the upper carriage will start to swing in the opposite direction. The swing procedure is now complete.
That's a clever setup, but doesn't that create a lot of heat?
No, not at all. That's a big advantage. By feeding the kinetic energy into the drivetrain, no additional heat is created. The upper carriage is decelerated by the hydraulic system. Oh, time's up. Only got the place till 4. How are we doing so far?
Great, but I didn't quite understand the function of the charge pump. Does the system leak that much oil when in use?
No, not at all. Like many other components on the machine, a certain amount of leakage helps to avoid unnecessary wear of the whole system. This leak oil is replaced by cool and filtered oil from the charge pump.
Oh, okay. Now I understand.
Let me sum up a few other important facts. Look, here is a flushing valve. It is responsible for the controlled release of highly stressed oil from the swing circuit. Note that this is a low pressure side of the circuit, as the high pressure side controls the position of the piston in the valve which vents a percentage of the circuit oil.
Good. I'll remember that.
Then here we have the blocking valves. They are very important as they separate the left side circuit from the right side. It prevents the inactive drive from accidentally being driven. The pressure of the driven pilot system opens the blocking valves.
Okay.
And last, there are the high pressure swing filters found in the circuit. These are inline cartridge type filters and can be found on the bigger machines, namely RH120, RH200, RH340 and RH400. A combination of check valves ensures the oil flow to be single direction. This is valid for RH200 and RH340 only.
I see. And why the extra filters?
That's easy. In case of contamination within the swing circuit, it remains isolated to one side of the system.
That's pretty clever. Say, can I ask you another question?
Of course. Fire away.
Can you use the swing mechanism with only one engine running?
Yes, that's no problem at all. Let me show you. We only start one engine. The hand lever is tilted and oil from the active side is pumped to the corresponding swing drive. Now look, half of the flow volume reaches the other drive via the synchronization lines between the two drives. Please note the importance of the blocking valves, which save the inactive drivetrain from being driven in the wrong direction.
And when both engines are running, but both at a different RPM, the volume of flow will also be different. Doesn't that harm the system?
No, that's okay, because the synchronization lines on all our excavator models ensure the volume of oil flow for the swing drives is balanced.
That's as easy as it is clever. Now, I want to keep the upper carriage in a stationary position. Can I do that with the swing system also?
For a short period, you can do that with the active system. But if you want to park the excavator, there is a multiple disc brake. There is a switch which operates solenoid Y31. The solenoid valve releases pilot pressure from the brake and springs press the discs together, thus blocking the swing gear. But be careful, the brake may only be activated when the excavator is in a stationary position. Otherwise, you risk damage to the brake discs, and that will cost you.
And we don't want that, do we?
Nah. Oh, and one last thing. As long as the retractable ladder and the service lift are down, the swing drives and the final drives are deactivated. The proximity switch for the ladder and the pressure switch for the service lift must tell the PLC upper position reached. If so, the CMS unlocks traveling and swinging. And that's it.
Nice. Thanks a lot for the information, buddy.
Don't mention it. Goodbye, Hank.
Goodbye, Power.
See you around, everyone.